I mean, I've been interested in sustainability, well, what is now known as sustainability, for a very long time. I was actually a student and I was interested in it back in the 70s. And I thought of it as more of an issue about resources and pollution and depleting resources and so on. So I was interested in how we could use less in the way we used our buildings and lived our lives. And it wasn't for some time before I got a chance to work on sustainable buildings. It was actually the late 70s, early 80s when I started working on low energy buildings, and that was really fascinating because it then opened my eyes to the idea that a low energy building in particular, with better daylight, better ventilation and all that kind of stuff, was actually a nicer piece of architecture. If temperatures rise 1 or 2 degrees in a mechanically ventilated building, people complain. But if it's a naturally ventilated building, people are much more accommodating, much more prepared to take rises and falls in temperature. I mean, here I am sitting on a reasonably warm summer day wearing a t-shirt, for example, and that's because a jumper or a jacket and a suit wouldn't be right on a place. So I adjust my clothing accordingly, and so do people in naturally ventilated offices. There's a whole completely different temperament comes with that kind of building, and building management has to recognise that. The people who commission the buildings have got to realise they have to change a bit as well. But it's an altogether nicer thing to do, so people embrace it pretty willingly, I find. In the south of England, the conditions are really rather different from further north you go. And we had done one building in reasonably far south in Coventry and 2 buildings up in Edinburgh, and we were finding the climatic conditions were quite different. We thought that in the south of England, natural ventilation on balance was probably the right way to go. And of course in winter you tend to lose a bit of heat out of the window, and so you have to watch the energy loss in winter compared with the energy saving in summer. We first heard of the Wessex Water project when an engineer rang us up and said, have you heard about this project at Bath for the Wessex Water company? It sounds like it's written for people like you. It was a sustainable brief. It had been advertised in the European Journal because it was a public sector type organisation, so it had to be advertised. And so here were engineers, in fact several got in touch in the end saying, this is a great sounding job, you ought to be going in for it. In terms of the building, they were very keen to establish targets which were ambitious and as good as anything that had been done up to that point. So we were talking about something like 100 kilowatt hours per square metre per year. What we would now describe that as is kilograms of carbon dioxide per square metre per year. But to give you an idea, the benchmark for a building like that is something like 90 kilograms of carbon dioxide for every square metre for every year. We got it down to about 30. Now, given that we knew that it had to be naturally ventilated, or could be naturally ventilated, I should say, we also knew from previous jobs, particularly the Coventry one, that the naturally ventilated office is a particular type of space. It's not too wide from one side to another. It's reasonably generous in its height because it doesn't need suspended ceilings and all the rest of it. It has opening windows on both sides and the air will flow. If you made it really very deep, that wouldn't necessarily be the case. And if you obstructed it by partitions, it would obstruct the airflow. So we had to arrange open plan office space in particular ways on relatively narrow office space to make sure the air would flow. We worked out that to get that kind of office space on the site, if we limited it to just 2 stories high to keep a low profile on such a beautiful site, it needed 3 wings of offices, something like 3 wings stepped down on the slope, 2 stories high, each wing looking over the roof of the one below, because of the contours. And then we linked them vertically, if you like, up the slope to form an E shape on plan. And that gave us long, thin pieces of office space where we knew we could open the windows and the air would flow. It was a very simple, naturally ventilated diagram. If you can imagine the E faced east, on the west side it faced an open field. That's where we put things like conference rooms, special facilities and things like that, which had to have some artificial air handling because of various internal conditions. So we used that as a buffer to the west sun, and everything else was naturally ventilated. We've not only got opening windows for people to use at the level of the desks, we've got an automatic vent high up in the space which works with a computer control. So if it's really hot in the summer, I'm not talking heat wave conditions, that opens up at night and the air passes through the building at night and cools the structure down. Now, it's a function of the weight of the structure as to how effective that is, but basically when you come in the following morning it's cool, and you're getting the benefit of radiant cooling in effect throughout the day till well into the afternoon before it starts heating up again. So you're not only getting the cool air through ventilation, you're getting a bit of radiant cooling for free from the structure. It has this vaulted concrete structure. It's actually supported on steel beams, but it's vaulted to increase the amount of mass that is exposed to this nighttime airstream. And we found it so effective, in fact the first year it was opened, the guy running the building was opening the vents all through the summer, not realizing it was cooling it too much. And it came in the morning, it was cold, he had to turn the heating on. So he had to get used to the fact you only use it in very hot conditions and the peak of an English summer when the heat wave might be lasting for several days and possibly a week or two or something like that. So it's not used very much, but it is the difference between comfort in really hot conditions and not. We do have a deep raised floor, and we do have the ability for some closed rooms in the depth of the building to supply ducted air through the floor. That also provides for a bit of resilience in future. If climate change really gets warm in future, we can put a bit more air on the floor at the peak periods of a hot season. So you've got to really be careful about these things, and you've got to think it through. It's not just a matter of saying, yeah, let's have an opening window. There's a lot more to it than that. And you've got to get it right, and you've got to think of how the occupants are going to use it for the life of the building. It's not just for architectural pleasure we do this, it's actually got to be working in the long life of the construction.